Alright JV, it's time to get this bastard back together. First thing, replace that standoff. Now these parts are still available. You can get them from CE Distribution. I might put the link in the description if I remember. If I don't, ask me in the comments. Giving the front panel a nice clean up. Got the EQ board back installed again. And the switches. So we'll chuck the boards in, reconnect them, and go from there. So now I've got to try and clean all this residue off the pots without disconnecting them all, because that would be an absolute time drain. There's residue all over the back of the pots. It's like someone sprayed it without a nozzle. None of this is necessary if you don't spray the lubricant around like a spider monkey on heat. See all the crud coming out of them on the paper. Part of the reason I put the paper there to clean it up, but also to see what's coming out of it. Like, how do you get the entire surface of the outer casing of the pot just covered in grease? They mustn't have one of those straw nozzle things that I've got, and they must just spray it straight out of the can just in the general vicinity of the pots. Wasn't that much residue on the chassis though, so don't know. Now, because we've probably taken a bit of the lubricant off the wafer in the process of cleaning it with isopropyl, we'll give it a blast with compressed air. Several blasts with compressed air, and re-lubricate it with Fatalube. Alright Jamie, so I've just got it running at slightly reduced voltage until we check everything, but just initially we've got a failed lead master pot. All the others seem okay, so we'll change that one out, we'll take some measurements, and then we'll see how it sounds. Right, so here's the pot in isolation, just connected to the Fluke. I've set the range to manual, so it's 10k. It's a 10k linear pot, so mid-range it should be about half that. But it's not, it's jumping all over the place. Moving the shaft back and forwards and making it go through the roof. And I got my doubts as to whether that's actually a linear anyway. It's hard to tell with their codes they got on there, I'll have to look that up, but either way, it's unpredictable. So in the bin she goes. Well, in the bag of shame anyway. As is always the case with Mesa Boogie, the plot thickens. So the lead master pot on the schematic is a linear, and the code that it calls up in the part list is 391278, which is a linear pot. The one that was actually in there is 391378, which corresponds to a log pot, logarithmic. So I guess we'll try the logarithmic. It seemed reasonably well responding in its position, so but yeah, there's always some little hiccup like that, and you got to do a bit of legwork to find out what the real deal is. Now, I don't know why they insist on using this uninsulated braid for all the grounds. If someone was in there and moved stuff around, you'd have all sorts of stuff shorting out. So I think I'll at least put some heat shrink on this right to the end, just to prevent any mistakes in the future. Alright, after messing around with that thing for way too long, we've got a new lead master pot installed. Anyone that's dealt with Mesas knows that their pots are kind of weird, and plastic shafted things with weird sizes, and sometimes you got to make something else work because there's just none available on the face of the planet. So I've got an alpha in there now, and that's working. I had to turn it around 180 degrees so the dial lines up because they're D-shafted pots. Given it a test, I'm feeding it with a variac at the moment. I've adjusted it to 240 volts. I'm regulating it to 240, 245. At the moment it's sitting at 240. Our mains is a little bit low today at 238. So adjusting it up to 240, which is supposedly what this transformer was wound for, we are getting 6.3 volts AC on the heater line, so it looks like it was wound for 240. However, our B plus is over 400 volts, 403 volts. That's loaded, and the screen supply is 325 prior to the screen grid resistors. Now, testing the bias in its current state with the stock values in the bias supply, which is what it came in with. We're at 96% on one side and 101 on the other. Now, recall that this is a fixed bias amplifier. Shouldn't be going above 70 for safety of the valves. It's like, again, another valve amplifier manufacturer has set the voltages and bias point up in this thing as if it's a cathode biased amplifier, and they're aiming for 100%. It's just ridiculous. So many do it. I really don't know why it's a thing with EL84s in particular. It seems to always be on EL84 amps. But so now we're at a bit of a crossroads. If we reduce the bias point, cool it down a bit, now the voltages will rocket up even higher, and generally all the voltages on the secondary of the power transformer will increase somewhat, but most will the one that will increase the most will be the B+, so the HT supply, and we'll start rocketing above 400 volts. So sort of can't really do much, unfortunately. Probably the best thing to do would be run this thing on a variac or like a brown box, but you can't buy brown boxes for 240 volts, and I don't really want to be trusting a customer to know how to use a variac, because pretty much all of them do go above 240 as well, so you got the potential to make things even worse. So this thing's just going to eat tubes forever and ever. Having said that, it's been alright up to now. Well, it wasn't, because it's been repaired a few times and it ended up here, but it's had a pretty good run. So I guess we just see how the valves go. If there's an issue in the future, we're going to have to do something like go for 7189As or get some esoteric voltage valve that can handle that high plate voltage. I guess that's our only option, and then bias it a bit cooler to bring it down to like closer to 80-70%, and some more sturdy types of valve will be able to deal with that higher plate voltage. That's kind of the only action here, other than controlling the mains voltage going into it. But as soon as we do that, then the heaters will be too low, so we're kind of bit of a Mexican standoff here with this amplifier. It's what will fail first. So now we've got consistent volume change across the travel of the lead master and the master. The volume's a bit touchy, but it is a very high gain amplifier on the lead. Take the foot switch dummy plug out, and now the lead master's out of circuit, and you've just got the volume and the master. So let's give this thing a sound test, and you may have spotted I've got the EQ on close to a setting that's pretty much the only way you can make lead channel sound any good on these things. It's just like my opinion, man. Go away, fly. So in light of those measurements, it's no surprise really that they end up cooking the circuit board in the area of the output valves. And as a repairer now, I'm kind of semi-responsible for this thing for the foreseeable future. So I'm at mercy of Mesa's engineering prowess. Alright, champions, so I couldn't help myself. I pulled the board once more and did some changes to cool the bias down a bit. So we've landed about 65%. That's the two resistors in the bias divider. It's sort of a weird setup. One resistor's tied to the tail of the PI and the other one goes to the bias supply. So you've got to change both of them to effectively keep everything on the phase inverter happy at the same time as cooling down the bias. So I've put them on this side. I don't like mounting components where they're not supposed to be, but in this case, if we need to change it again, or if a new set of valves gets installed and those values need tweaking, now they're at a place on the board where you can easily access them to change them out. So here was the specs before doing those changes. You got 96% on one side and 101% on the other. Mind my handwriting, and it was drawing, in quiescent play mode, like switched out of standby. It was drawing 70.5 watts at 240 volts AC on the mains. Once we've made the changes, that's what I did. There's our new measurements. So we're landing at 65 on one side and 59 on the other. So a bit of a mismatch thanks to the valves being out of match a little bit. But our voltages have gone up significantly. We've got 425 on the plates now. The screen's 342. It was, where are we? Screen 325. So that hasn't gone up heaps. So I don't think we're in too much trouble there. But this thing's not going to cook itself to death now, so that's good. Let's get this thing back in the cab after cleaning it up and do some little sound samples if my chops are up to it, which I dare say they're not. Another kind of silly thing is they put a shielding piece of foil there and they spray paint over it. You couldn't write this stuff, eh? So there you go, champions. These things take a bit of taming, but once they're sorted, they actually sound pretty good for the full-on metal shit. And on the clean channel, you get a nice crunch as you turn up the volume as well and turn the master down. Or just let it rip, turn the master up, and get a bit of output tube saturation as well. They're kind of not the most versatile with respect to switching channels because there's no independent gain for the clean channel versus the lead channel. So you can't dial in a nice crunch and then just have a mild overdrive on the lead channel. It's going to be extreme. So I guess that's why they progressed to the DC3 series and DC5 and whatever and beyond, because it had two pretty well independent channels. But you know, piece of history. Even if it is a Mesa Boogie, sometimes I've got a bit of a soft spot for them when they play nice anyway. This one wasn't too bad. I've seen a lot worse. Now it's cooled down quite a bit. She should last a pretty long time. So I'll see you on the next one, legends. Thanks for your patience on this. I'm going to try and get them down to 2-part videos unless there's something particularly epic about some repair or heroic. So like, subscribe. You know you want to. All the cool kids are doing it. You know. Well, they're having a smoke out behind the bike shed. So if you want to be a cool kid, you do it too.